Okay, now we're going to build our most complicated circuit yet. We're going to build a circuit that's a combination of a 3-color LED, an RGB LED, and a photosensor. So it's going to have both an output and an input. The 3-color LED looks just like one of your red and green LEDs, except it's frosted white like this. And instead of having 2 pins, it has 4 pins. All 4 pins aren't the same, and you notice there's one longer pin. The way this works is, this one's the red, and then the long pin is a common pin. It's the ground for all 3 LEDs, and then the green and then the blue LEDs. Your LED may have slightly different wiring, and so I'll talk about that in class. But if you've got the Adafruit one, it should be wired just like this. So, when you have the LED, put the long pin should be the second pin from the left. Put it into the first 4 columns, which is 30 through 27 in the way I have the board laid out here. And get 1 pin in each of the 4 holes. Now it's a little tricky to do that. It might take you a little bit of hassling to get it to work. Now, just like with the red LEDs, the red, green, and blue LEDs in here each need to have their own resistor. So again, we're going to use a green, blue, brown resistor, a 560 ohm resistor. And for each of the non-ground pins, we're going to wire 1 resistor to sort of jump over the break, like this. Let's see if I can get that in. Okay, we're going to keep trying to wire this in. Sometimes with the new breadboard, these pins can be a little finicky. There's 1. There's 2. And there's 3. So notice carefully that I have 1 and then a break, right? There's nothing plugged in there, and then 2 and 3. That's important because, well, the middle wire there, that second, that's the common wire, and it has to be wired separately. How does it have to be wired? Well, we're going to wire that one. I'm going to come in on the back side to 5 volts. They share a 5 volt, not a ground. That's called common anode, and that's the wiring that the Adafruit kit comes in. So I'm going to hook up the common wire to 5 volts, and then I'm going to hook up my red, green, and blue wires to their respective pins. What pins do the red, green, and blue wires go into? Well, I had to pause for a second to look it up to make sure I got it right. So the red, we're going to connect to the bottom end of the resistor. That goes into pin 11. That should be the pin right next to our button here. Now we're going to skip over the break and plug into the green. That goes into pin 10. And then right next to the green, I'm going to plug in the blue. And that goes into pin 9. Now you don't actually have to use red, green, and blue wires for the red, green, and blue LEDs. But I like to because, well, I don't know. I'm OCD that way. Okay, so now we have the RGB LED wired up. Okay, let's test the RGB LED. we plug it in. Normally it'll be off when we start. Now with the first LED lit on this side, we should see red, then green, and then blue, and then white. All LEDs on. That's how we know the LED is right. Now, if you don't see one of the LEDs, check the corresponding wire. And if you see the reverse color, so instead of seeing blue, you see orange, or yellow, which is a combination of red and green. Instead of seeing green, you see purple, which is a combination of red and blue, sort of the opposite colors. If you see that, then your LED is wired as a common cathode and not a common anode. And that's okay, that's just fine, but we need to fix that in software. We're not going to fix that with wiring. We're going to actually change the program in the Arduino to make sure that it uses the LED correctly. So if you see that, that's okay. Leave the wiring the way it is. Now if you're missing a color, just make sure that you double check all your wires, that they're all plugged in the right places and that your resistors are fine. All right. So now we're going to add the light sensor. Okay, now we're going to add the light sensor. The light sensor is another analog part. Looks just like this. You can see sort of some squiggly lines right there. The way this works is, well, the more light hits it, the less resistive it gets. And so light causes electricity to be able to flow between the two leads. Now the way we're going to do this, it's important that we arrange the light sensor kind of near the multicolor LED. And just like the light sensor, we need to make sure that we have a 10K resistor. That's going to form a key part of the analog circuit. So we're going to put the 10K resistor between ground and, in my case, column 26 here. And then we're going to put the light sensor. Now the light sensor's got some pretty long and picky leads, so you got to be a little careful with it. I'm going to put it between columns 26 and columns 24 there. And then I'm going to use a wire real quick to wire between column 24 and 5 volts. Just like that. I kind of try and keep the wire sort of neat and tidy in there. I can always go back and rewire this if I need to. And then on the same column with the resistor pin, column 26 in my case, I'm going to connect this to the A0 pin, the analog input 0 on the Arduino. So now the Arduino is going to be able to read the amount of ambient light that is present when we are running. One important thing that you should look for when you do the light sensor input is eventually we're going to make something that can test for the different colors, that can basically measure the intensity of colors. And when we do that, we're going to put in a little separator, like a piece of cardboard, or in this case, a business card, between the color LED and the light sensor. So however you have it wired, however you've done it, just make sure that you can kind of get a little piece of cardboard in there and that the cardboard is kind of held in place. That's going to be really important to get accurate readings. So how do you test the analog sensor, the analog light sensor? Well, I couldn't think of a way to do it given our existing LEDs and buttons. So the only way to do it is when you plug it into your computer, when you open up Arduino's serial console, you're going to see the reading output from both the analog squeeze sensor and the analog light sensor And what you can do when you're looking at that serial console is you can make sure that when you put your finger over the light sensor that you see the reading deflect. There's no way to do it exactly with these buttons and switches. So when you've got it built, just make sure you plug it in and check to make sure that the sensor is there, and it seems to be reading correctly.